So, what we saw before is that it can be hard to reason about randomness, especially when you have limited data. And you will almost always have limited data because of we cannot roll a die infinitely many times in practice. Hypothesis testing or significance testing is one framework to guide our thinking. I'm going to stick with the term hypothesis testing, but know that I mean that entire concept, which you might have also heard called significance testing. So let's go through what it actually looks like to conduct one of these hypothesis tests. So let's turn to another example, and that is Melvin is running for mayor. He's got this excellent hat. He's trying to, you know, show everybody that he's going to be a great candidate for mayor. And he has some exciting policies for our neighborhood. He just gave a rousing speech, and he's promised that if you elect him, he will give every house a dozen eggs. Wow, quite cool. Now he wants to know, did his speech win him any votes? Right? Good question. You want to know when you give a speech with this amazing new egg policy, did it win the hearts and minds of any of our voters in town? So let's investigate this through the lens of hypothesis testing. Luckily, our town has a pollster, and the pollster says support for Melvin has been holding steady around 60% recently, and today it went up to 70%. Okay, that's cool. So Melvin, of course, is thrilled by this. That is so promising. It sounds like indeed, yes, after his speech, his numbers went up. But wait a second, says the pollster. It's normal for poll numbers to go up and down just by chance. Remember that polls are samples of the whole population. And every time we take a poll, we're going to sample slightly different people, right? So most of the time, we're not going to exactly repeat who gets asked their opinion in the poll. So because of the people participating change every time, it's normal for the results to fluctuate a bit. And if this sounds unfamiliar or you want to refresh it, go back to part one. We've got a lesson about how noise can get into polls there, which I recommend rewatching if you want some review of this. So we have an important question here. Did Melvin actually gain any support, or is the change in the polls probably just noise? So here's how we're going to go about this. We're going to, step one, set our hypotheses, and that has a particular meaning in this framework. So by convention, we're going to start with something called the null hypothesis, and it's a statement about the world that is the most boring version. So we're saying, what if everything is just business as usual, nothing interesting is happening, this is what we think is true. And that is here, after his speech, Melvin is exactly as popular with voters as before. And then we're going to create an alternative hypothesis, which we'll abbreviate with this H and then a little a. And this is something that can't be true if, it's mutually exclusive with the null hypothesis. And that is after the speech, Melvin's popularity with voters has changed. And you might notice this is kind of a vague statement. It doesn't say why his popularity has changed or by how much or in which direction. Did it go up or down? That's pretty normal for hypothesis testing. This is a fairly vague statement. It's just that his popularity has changed. Now, we're going to want to, these are nice, but these are going to be hard to directly test. In fact, if we could measure everyone in the population to know exactly how truly popular Melvin is, we might not need this at all. But we don't know how to directly access Melvin's popularity because if we've only got this poll, which has some limits to it, right? It's finite. It doesn't measure everyone. It just samples some people in the population. And then, we try to extrapolate that to understand broader trends. But, we've got to turn this statement into something that we can actually test with the sort of data we can really collect. And so let's talk about it in terms of Melvin's, percentage of how popular we think he is. And so let's say after the speech, 60% of voters support Melvin is going to be our null hypothesis. And that's based on, the pollster's report that he thinks that, looking at the data of the last couple weeks, he thinks that there's truly 60% of voters that support Melvin. And then our alternative hypothesis will mirror the null hypothesis here. After the speech, support for Melvin among voters is no longer 60%. Okay, so now that we have kind of turned our original statement into something that's numeric and that we can really, make some measurements that we think address, we can actually explore this better. So step 2 is that we're going to visit the null world. What does this mean exactly? Well, we've got this guiding question in mind. Is it plausible to observe our new poll result if Melvin's support is still 60%? So I'm going to say this one more time. The question that's going to be guiding us throughout our hypothesis test is this. Is it plausible that we could observe our new poll result, where Melvin came up at 70%, if the true support for Melvin in our town is still 60%? And this is our null hypothesis. So we're saying, is it plausible to see what we see if the null hypothesis is true? And we can answer this with math. So a lot of the math behind this is more advanced in particular than we're going to cover here. There's lots of introductory statistics classes that are going to go through the algebra of what this means with you. But we're going to do it just through a sort of intuitive explanation instead of, a really technical explanation. So we're going to imagine, what if we had conducted the poll many, many times in the null world? The null world being where Melvin truly has 60% support. So we're going to, using math, we're going to imagine what had happened if we had conducted the poll again and again and again. And what's different every time we conduct the poll? We're going to be sampling slightly different people to be in it. So if we imagine conducting the poll again and again, we would see that there is, I'm going to plot what would happen. So we're going to be looking at a distribution here. So on the bottom, we're going to be showing our survey results. So how popular would Melvin come out in the poll? We're going to be looking at how often that would happen if we conducted the poll many, many times. And we can see that, as expected, if the true popularity of Melvin is 60%, so if he's really got 60% support, then if we repeated the poll again and again, most of the time it's going to come out, it's going to be symmetrical around 60. We think that 60 is going to be sort of the peak. It's going to be, quite common, and that's because it is the true value. But there is going to be some variability, right? It's not always going to be 60. And why is this? It's because of, the poll only has a finite number of people in it. It doesn't represent the whole population. And in fact, the polls always have 100 animals in them. So our pollster goes to 100 houses that are randomly selected in our town and asks, who are you voting for, and records it. So because of it's a finite and random sample, it's going to give us some variability around 60%. We won't always get the same result. So this distribution here represents all the possibilities that we could encounter if the null hypothesis is true. So if support is really 60% and we repeat the polling procedure, we're going to see a distribution of possibilities where it's often 60%, but not always. Sometimes it's a bit more and sometimes it's a bit less. So the next step is that we're going to check how compatible our data, our new poll, is with the null world. Now, how are we going to define compatible? So here's sort of what we do by convention. We're going to shade an area of our distribution. And this area is going to represent most of the possibilities. And I'm going to follow a convention that says that we're going to fill up the middle 95% of the distribution here. Why 95%? It is a bit arbitrary. It should feel a little bit funny just to say it's 95%. We're going to come back to this later, but it's a sort of convention, and I'm just going to follow it. So we are shading the middle 95% of this distribution. So 95% of observations in the null world are going to fall in this range. And that looks like a little bit like, maybe 51 or 52% to maybe like 68 or 69%. So this range here, we'd consider pretty unsurprising in the null world. So if Melvin is, not changing in his popularity, if he's still got 60% support from the public, then it wouldn't really be that surprising at all to measure a poll in this range. So where do our new poll results fall? We draw this dashed line here, And they're actually just outside of the range, right? So they're just outside the range. We're not in that shaded region. So because our new pole is outside the shaded region, this means it's not particularly compatible with the null hypothesis, right? We created this blue range. Everything in that shaded range is, what we're saying is pretty ordinary, very compatible with the null hypothesis being true, and we fell outside that range. So let's return to our hypotheses. We had two of them. After the speech, 60% of voters support Melvin, and after the speech, support for Melvin is no longer 60%. And we're going to cross out this, right? We said we reject the null hypothesis. And that was because we found that if we imagine the null hypothesis to be true, and we looked at all the possibilities of what could happen if that is true, our new pole falls quite, it would be quite surprising to us if the null hypothesis were true. So we say we reject it, and rejecting the null is the language that we use in this framework. So in plain language, we have some evidence that Melvin's gain in the polls is real. Now, if this was all a bit overwhelming and confusing, that's okay. It's actually pretty normal for that to be true because if this is a concept that scientists frequently, struggle with, and even people who are, years into their careers will, struggle to articulate all the parts of it. So we're going to go over this again, and we're going to recap what we did next. So if you just, got a rough flavor for how this works and the sort of thinking that we're doing, that's really enough. That's a great place to be right now. So next up, we're going to recap and we're going to talk through all the parts of what we did again.